Good evening, all. Good evening. Chin, are you sleeping or what? Get up. Good evening. You are welcome to the tutorials with From a Time to the Schoolboy. Today we'll take a look at chemistry review, assignment 5. We'll review the fifth assignment. So I hope you did it. Who did not do the assignment here? Who did the assignment here? Who has the assignment? Were you in our last chemistry class? You to understand because you weren't there now. So you would understand. Okay, this assignment was given yesterday. You were not here yesterday. Have you seen our new timetable?
Yes, I've been
What do you have today in the timetable? No, I mean the timetable, not your course.
when I took time,
Okay, only your own chemistry. Okay. So like today now, that means see what you. When else do you have chemistry? There. On Tuesday. Tuesday. Okay. All right, let's continue, please. Okay, the quick number 1 says the presence of an impurity in a substance will cause the melting point to A, increase, B, be stable, C, 0, D, reduce. What's the answer? Reduce, right? Good. Once there's an impurity, the melting point to do what? Reduce. Thank you. Number 2, which of the following substances is a mixture? Sulfur powder, bronze, distilled water, ethanol. Which of them is a mixture? Chinaya? Which of these is a mixture? Sulfur powder, bronze, distilled water, ethanol. Bronze. Is it true? Bronze is an alloy, so it's a mixture of what and what? And what? Copper and tin. Are you sure? Number 3. Which of the following processes does not lead to a chemical change? Which of the following processes does not lead to a chemical change? A, stirring iron in sulfur 6 acid. Stirring iron in sulfur 6 acid. B, stirring sodium carbonate in water. C, mixing sulfur 6 acid with potassium carbonate. D, titrating an acid against a base. Favor, what's the answer? You think? You don't know? Why do you say B? Why do you say B?
okay, does not lead to a chemical change. There's no chemical change there. It just extreme sodium carbonate in water. There's no chemical change.
So what happened there? And now explain what happened when you stir sodium carbonate in water. What happened? What happens? You don't know.
I know it's not a chemical change.
Okay. So what happened now?
It's a physical change. If there is any new substance that was formed, then it's a chemical change.
So
you
what?
can actually separate both of them. Sodium carbonate, I think, is salt, one part of salt.
Michael.
It's a salt.
Yes.
Michael. Huh? Is it what? Why? Say your own. Stop pointing at us. Say your own. Why do you think so? If water reacts with sodium carbonate, no new substance will be created. Are you sure? Achille, what do you think? Okay, thank you. The answer is B. Stirring of sodium carbonate in what? Water. It will just dissolve. Am I communicating and form an alkaline solution? That's all. Are we together? Not that it will start forming something else. Okay? Unless you cool it, that's how you do it. You can, if you dissolve that's how you dissolve it and now cool it. It will crystallize out as washing soda. What's another name for washing soda? Sodium what? Washing soda. Sodium what? What is washing soda? Having there of sodium ribocarbonate for decahydrates. It will crystallize out and form and now acquire 10 molecules of water of what? Crystallization. I'm not getting that one is another thing. I just want to point out something. But the answer is what? B. Stirring of sodium carbonate in what? Water. Good. Number 4. A small quantity of solid ammonium chloride was heated gently in a test tube. The solid gradually disappeared to produce a mixture of two gases. Later, a white cloudy deposit was observed on the cooler part of the test tube. The ammonium chloride is said to have undergone A. Distillation, B. Sublimation, C. Precipitation, and D. Evaporation. What? Sublimation. Good. So, can someone name the two gases that came out? From the question. The question says gradually disappear to produce ammonium chloride disappear to produce a mixture of two gases. What are the gases? And what? Chlorine. Talk now. Ammonia and what? Hydrogen. Aparo. You don't know. Success. Okay, success say chlorine gas and ammonia gas. Michael. Chinwe. Okay, look at this. What other gas now do you think ammonia can combine with to form ammonium chloride? Just look at the formula for ammonium chloride and tell me the possible gas. Hydrogen gas. So if hydrogen gas reacts with ammonia to form ammonium chloride. So even just by looking at this is the formula for ammonium chloride. So by looking at this thing now, you don't know what gas will likely combine with ammonia to form this. Chlorine. Okay, if you put chlorine there, to form what? What is this one? What does this one mean? This is the same thing. Good.
Okay.
Okay. How can hydrogen chloride?
How can what?
How can it disappear in the air?
Hydrogen chloride and hydrochloric acid are not exactly the same thing. No. Hydrogen chloride gas and hydrochloric acid. No. That's what I say. You're talking about hydrogen chloride gas. Oh, chemistry.
Hydrogen chloride and what?
Look at it now. Look at it now.
Ammonia and NH2.
Is it not?
You know, it's just that you're not able to recall.
Are you serious? You don't know it now. Once you can't recall, you don't know it. You relearn it. Let's continue. The answer is actually what? Sublimation. I agree with you. Okay, here. Number 5. Which of the following are mixtures? Which of the following are mixtures? I. Petroleum. B. Rubber lactase. I. Rubber lactase. I. Vulcanizer solution. IV. Carbon 2 sulfide. Then option A. I and I. Option B. I and IV. Option C. I and I only. Option D. I and IV. What's the answer? A is what? Rubber lactase. What is vulcanizer solution?
It's a solution of
Emission of rubber and sulfur that is heated.
You say what? Say what to say.
it's a solution.
And what?
And rubber.
Only somewhere you know.
The emission of rubber and sulfur heated to a temperature now.
To a temperature.
That is organization.
Chinaya, what's the total of vulcanization? Oh yeah, you must answer it. If you don't answer this one, I'll deal with you. Now, yeah, tell me. What is content of vulcanizer solution? Fast. You were here when you did assignment, right? I gave you an assignment. So what are you saying? What are you telling me? Check here. Did you do it in your notes? Michael, you were there when I did the assignment. What's your content of? You can't remember again. Come on, where did you write it? Where is it? At home. Why do you always make this mistake every day? What? Phosphorus, sulfur, and what? Rubber. But the most important is that it's a what? A mixture. Good, thank you. Number 6. Allotropes of an element differ in their A. Physical properties, B. Chemical properties, C. Mass numbers, D. Electronic configuration. Chemical properties. What are even allotropes? What are allotropes?
Allotropes are defined as a various form an element can is a various physical form that an element can exist in different forms.
Example.
Hydrogen.
Is what? Are you confusing isotopes with allotropes? What are allotropes?
Yes, it's I use what
Give an example.
We have carbon dioxide.
She's going back to isotopes again. And who knows? What are allotropes? You defined it and you are giving me examples of isotopes. I agree with you. So examples. What are the allotropes of carbon? Diamond and what? Another example. Another example of allotropes. So what are the allotropes of sulfur? Rhombic and monoclinic or sulfur. So what's the answer now? The answer is what? It's just the same thing. Everything is the same thing. It's just the same element. Just how their physical properties. Because of difference in their forms. Okay, it's the same thing. Nothing, no mass number, no change in anything. It's just the same thing. I'm not complicated. It's just that they exist in different forms. Okay, so it's just based on their difference in their physical properties. Number 7. List 2 physical properties used as criteria for purity of substances. Density. Mass. What are you saying? Volume. Okay, so you use volume to detect the purity of substances. Boiling point. Melting points. Boiling point, melting what? Points. So describe how you can use boiling point to determine the purity of success. Just describe how you can. This person, just talk to me. How you can use boiling point to determine the purity of a substance. You don't know what to say. What do you have to say?
Normal boiling point of a water that is not containing impurity, but when there is an impurity, the water tends to boil above 500 degrees.
Okay, so how will I use that to determine purity?
How you read it that you shake, you bring a water that has no impurity and one that has, so you boil like you put them like on a fire at the same time, then you shake when the other one boils and when this one boils.
Okay. So if someone is claiming that this thing is water, I look at it, the color is like water. You even test it safe. If you can take the risk, and it's still water, you carry out you now say, okay, I want to be sure that this is only water. There's nothing else inside it. You can check the boiling point. If it boils above 100 degrees Celsius, then that thing is not what? Water. Am I communicating? Because the impurity will elevate the boiling point. We call it boiling point what? Elevation. So, Favor, tell us, how do you not use melting point to determine the... Favor is busy copying English. Tell us how you use melting point to determine purity of a substance. Just do what? Melting point. I don't melting point. Tell us. Don't know. Are you serious? Who will tell us? Who knows?
According to what she explained, melting point. And then if something like you bring two solid or fluid substance and you want to determine to know the one that is pure and the one that is impure,
Mm-hmm.
you can keep the pure one with the freezer, you melt at 0 degrees C. But if there is impurity in the substance, it will reduce the melting point of that particular substance.
Of course, most of the substances, well-known substance, chemicals, this thing, their compounds, elements, their melting point have been established, and it's in the literature. It's recorded as standard. So, if somebody is claiming that this particular solid is this metal or is this compound, and you want to be sure that it is this thing, just get that one the person is claiming that is that compound and melt it, and check the temperature at which the thing now melt. Now compare that temperature with the temperature they said in the standard. If it's far, if you below that temperature, then it's not what? Pure. And also if the temperature is a range, it shows that there are other substances in it. One it need to be a range. The second is that it will be what? Less than the what? Even the range will be less than the normal melting point of that what? Substance. What are you doing? Aparo, I with us in this class. You are not contributing. Why? You're not going to do. But you will do whatever else. Aparo. Huh? Say what? Is what? Okay, your name is not Aparo. Chineye Aparo. Okay, I should stop calling you Aparo because it's not your name. It's your father's name. Child. No problem. Okay, now let's continue. Melting and what? Boiling point. Number 8. Pure water can be made to boil at a temperature lower than 100 degrees Celsius by A. Reducing its quantity, B. Decreasing the external pressure, C. Distilling it, D. Increasing the external pressure. Huh? Increasing what? How? Increasing. How?
Going to be lower than 100 degrees distance.
When what?
You will decrease the temperature now because.
You say what? What are you saying? Okay, you don't understand that. Wait, you don't understand that you're talking.
No.
She said she doesn't understand. She's asking what she doesn't understand.
I'm asking the question now. Stop.
No, but you just say now you don't understand. And you're answering.
You said that pure water can be made to boil at a temperature lower than 100 degrees centigrade by how now? I'm not telling you that by decreasing the external pressure.
So how does it affect it? How?
I'm not trying to tell you. I'm trying to explain now.
Explain. Stop trying. Explain. I explain.
I said that when a liquid is heated in a container, there is a gradual increase in the average kinetic energy of the particles. Then with time, the liquid starts to evaporate. But when the vapor pressure of that liquid is the same as the atmospheric pressure, the liquid boils. Therefore, liquid can boil at any temperature by altering the external pressure. This is the principle there is the amount of pressure that is being exerted on a liquid that is being boiled. If you increase it, the more you exert more pressure on it, the more it increases, heading to 100 degrees centigrade or more than, depending the kind of liquid you are boiling. Then, but if you decreases the external pressure, that is being exerted on it, then the boiling point decreases. It will get up to. Am I wrong?
I'm listening to you now.
Up to 100 degrees centigrade. But what are you thinking about? I don't know. I didn't explain very well. I don't know how to.
Actually, what happens is this. We define boiling point at the temperature at which the vapor pressure is equal to the what? Atmospheric pressure. And the atmospheric pressure is external, true of us. It's not within the container, right? It's external, right? Now, so if the atmospheric pressure is very high, the vapor pressure will be increasing until it become equal to the what? And as temperature, and for the vapor pressure to increase, that means the temperature will be increasing, right? Because you know that as the temperature increases, more kinetic energy is impacted in the what? In the molecules, right? And they exert more what? Pressure. Not on a normal, pressure is directly proportional to what? Temperature. True of us. So that means as the temperature is increasing, the vapor pressure will be what? Increasing. But it will not boil because the vapor pressure is not yet equal to the what? External what? Pressure, which is very high. So the vapor pressure will just be increasing until you get to that becomes equal to the what? Atmospheric pressure. But if the atmospheric pressure is very low, it will take the vapor pressure time to become much time and much temperature to become equal to the what? Atmospheric pressure. It just a slight increase in temperature will bring the vapor pressure up to become equal to the what? Atmospheric pressure. So if you want it to boil below 100 degrees, just work on the what? External pressure. Decrease it. And if you boil well, be above what? Below the boiling point. Does it make sense?
Yeah?
Does it make sense?
Yes. According to my own business, what I understand from it is that the easy and more dramatic way to see the boiling point.
Are you saying what you understood or what you copy from
What
to
I
read?
understand now, I read it and
Yeah. Let's hear it. Fast. Let's hear it.
easiest and the most dramatic way to change the boiling point is by tampering with the pressure.
I agree with you.
That's same thing that you say. The one that's above the water. The lower the boiling point, the lower the boiling point, the heat supply to decrease its external pressure. Exactly this thing.
What does it mean?
What I understand from it is the same thing that you are saying. I don't understand that. Oh, I don't know where to go.
She's just asking my question. But it's okay. What is it? Hey, come here. Where is it? No. Go there. Sit here so you can focus. Two of you, I don't understand again. Sit here so you can focus. Fast. Go there, fast. Now, so that's the answer. Actually, the answer is what? B. Decreasing the what? Vapor what? Sorry. External what? Pressure. Thank you. Now, number 9 says, explain why the boiling point of chlorine is lower than that of iodine. Okay, answer.
Chlorine has larger molecules than iodine, meaning it has less intermolecular force than iodine.
Chlorine has larger molecule than iodine. Are you sure? No. What is the atomic number? What is atomic number of chlorine?
17.
Iodine uncle.
Iodine.
What is mass number of chlorine?
Mass number 36.
Relative atomic mass anyway. So how do you say that chlorine is larger than chlorine and iodine? Which one is larger?
Sorry, iodine has larger
Than what? And so what is the implication? You say what? Chlorine has what? Lower or higher?
He said
Yeah. Why chlorine? Why the boiling point of chlorine is lower than that of iodine? A lower what? Why? Are you okay? Huh? Try. Oh yeah. Okay. Who knows? Who knows? Who knows? Who knows? You say what? You have few points. Give us few points of that few point of yours.
Answer is that iodine has a larger molecule than chlorine.
Molecular, okay. You measure.
But see that iodine has more intermolecular force.
Link it up now. Link it up now. Just link up these things. I need a link up. I'm hearing that larger, smaller. Link it up to the reason question. Let's hear her. Why? Why? Then why does iodine have? Why does it have more inter whatever force? Why? Talk. I like what these two men be. I like what they are doing. You know, they will go look into it. It makes it class with life. I enjoy it. Two of them. Michael is working up a bit. You are, I don't understand what you are doing. Chinwa, I don't understand you again. Chinwa,
You know that this thing, they are under
talk now.
And they are noble gases.
You say what?
Both of them are noble
It's going no.
iodine, sorry.
It's iodine. What I say?
Wait now, calm down. Iodine and chlorine, they are gas now. It's an element.
Continue.
Because they have
I'm missing road to bring me back. Not for my hair.
Because they are even if it's one where the boy. What happened? See, listen carefully. What you said is not that chlorine has smaller molecular mass. I agree with you. Iodine has larger molecular mass. I agree with you. But I want you to link it. I agree with you. Strong intermolecular force and weak intermolecular. I agree with you. But I want you guys to link it up to the question we are talking about. Is that linking is the problem? Explain why boiling point of chlorine is lower than that of iodine.
The reason why chlorine has a lower intermolecular force because it has less electrons in the atom than iodine.
So what happened? This is chemistry. This is science. It's not just wow. It's just segment. Link up your views. You see, to just smoothly make sense. Everything you are saying, but what you're saying is disjointed. Everything you said is true. This one has a fewer electrons. I agree with you. This one has more electrons. Even by virtue of having higher molecular mass. By virtue of having higher molecular mass, I might talk communicating. By virtue of iodine molecule being larger than chlorine, electron in iodine must also be larger than that of chlorine. But how does it affect what I'm saying?
But I thought chlorine, when an atom share with 7, so only the one electron completed the orbital.
I agree with you.
Because they could do that now, chlorine will lesser. Nke iodine now.
But basically, okay, let's not waste our time. Let me help you to link the distance. Every point you made here is correct. I agree with you. But all the linking now is not the issue. You link your answers, your point to whatever you're answering. That's what will make it make sense. Now, I agree with you. Basically, iodine is larger than what? Chlorine. Now, iodine being larger than chlorine, another thing there is that, of course, it should have more electrons than chlorine, right? True or false? It will have more electrons than what? Chlorine. True or false? Now, you know that intermolecular forces, if you see chlorine, you know the number of molecules. This is the force that exists between what? Molecules. You know now, if you say chlorine now, iodine is I2, right? Chlorine is Cl2, right? Now, what is holding this chlorine and chlorine molecule? Chlorine molecule. What will hold them is what? Intermolecular what? Forces, right? Specifically, one now one. Am I communicating? Even I give. Now, but the point there is that the two of them now, because iodine has more electrons than chlorine, the one in iodine will be what? Will be what? Stronger than that in what? Chlorine. Are we together? Because the more electrons, this is just attractions. Hope you know. True of us. The more electron, there will more high. The stronger what? What our force in what? Chlorine and iodine to compare with what? Chlorine. So because of that now, it will take more time. In fact, the more heat will be needed, more energy will be needed to break down the what? Intermolecular forces in what? Iodine than that of what? Chlorine. So that's why chlorine boils at a lower what? Has a lower boiling point. All things being equal, if two of them are subjected to the same atmospheric pressure, hope you know. True of us. Two of them must be placed in the same atmospheric pressure. True of us. Not when you bring place iodine in a very low atmospheric pressure. It will boil before chlorine. True of us. It will boil before chlorine. But if two of them are subjected to the same atmospheric pressure, external pressure, chlorine will boil faster than before what? That's why its boiling point is what? Lower. Do you now agree with me that your point has been disjointed? It's just like this. Boom. You need to do what? Link it. Examiners, when people are marking questions, maybe those that will write WAEC among you that are marking, these are the point. You need to link your points. Link it. It's very, very important. Okay? Alright, so the answer is what? I think I've said the answer. Number 10 says a mixture of kerosene and diesel oil. I say you should come here. This is where I say you should come. Come here fast. Ever answer it there? Ever? Fast. Favor, come and sit here. If you turn again, you will come here. I carry this seat and put here. You sit down here. Better sit here. Don't look this side again. Now the answer is what? Okay, a mixture of kerosene and diesel oil can be separated by the same way success and successful have been separated by A, crystallization, B, distillation, C, precipitation, D, sublimation. What's the answer? What's the answer? Chine, what's the answer? Distillation. Wow. Chine say distillation. That's good. Chine has spoken. The answer is what? Distillation. I agree with her. You see, Chine that spoke. I agree with her. The answer is what? Distillation. But if you watch, this thing is just distillation, okay? It's the most appropriate option. Hope you know.
Yeah.
Yes. You know, they didn't specify the type of what? Distillation. Hope you know.
Yes.
Hope you know. Do you know that that's how the question will be? That's how the question will be. If they want to confuse you, they may put fractional distillation here. Which one will you pick? Three of us. Is it clear now?
Yeah.
Yes. But let's just not talk too much about that because Maybe why they didn't put fractional is because it's just only two components. Hope you know. Are you there? Maybe that's why they didn't put it. But the correct thing for petroleum product is what? Fractional what? Distillation. Because they have very close boiling what? Point. True of us? Maybe if we check boiling points of kerosene and check boiling point of diesel, if they have up to 10 degrees Celsius apart, simple distillation can do that. True of us? But if they are very close, then fractional is one that will do what? That will do it. All right. So I think we've done justice to chemistry review for today. I want to thank you for your attention, and see you next time. God bless you.